phase shift. Phase shift is nothing else but horizontal shift, horizontal translation. So when graphing a function y is equal to sine 2x plus pi, we need to factor 2 out to get the horizontal shift. In other words, phase shift. So for this function, we have y is equal to sine, and we do factor 2 out, and I have x plus, if I take 2 out, I need to divide the pi over 2. Because when I multiply this, I would have pi. So the phase shift is pi units. This one is horizontal shift, or it is phase shift. Horizontal shift is called phase shift. Okay, so we have phase shift pi over 2 to the left. Pi over 2 to the left, not pi. We do need to factor that 2. So if we would like to graph this function, the plan would be like this. We start with the sine graph, then we compress it, then it's multiplication. So this number is inside. This number is inside sine, so it's horizontal compression. We would squeeze the graph. So if my original graph was like this, S shape, then the squeezed graph, it would be compressed. In 2 pi, I would have already two periods, 2 cycles. And then number 3 would be y is equal to sine, and then we have this 2x plus pi over 2, and then we have horizontal shift pi over 2 to the left, or in other words, phase shift. Let's take the minute about the compression. Okay? If I have function y is equal to sine x, and then I would like to draw sine 2x, my graph is compressed twice. Horizontal compression, it's inside. Horizontal compression. Twice, 2 times. So what's happened with the graph? From pi to 2 pi. My original graph is like this, sine x. That's the original graph, sine x. And now I compress it. I squeeze that graph. I take the graph and I just squeeze it horizontally. So what's happened with the graph? I would have whole shape in just 1 pi. So I'm dividing that pi half, so the graph would look like this. Whole shape is in 1 pi. Okay, so this one is y is equal to sine 2x. And the period, what's the period of the new function? Okay, period is just pi, compress it twice, right? So the whole S shape, now the whole S shape is just in 1 pi. So we divide that pi by half. By half is my one bump, and the other bump is on the other part. Okay, so how do we calculate that period? How do we calculate the period? If I say that I have y is equal to sine 2x, I consider this, let this be the number k, a number k, right? So period of the original sine function is 2 pi, and now we need to divide by this one. So the period of new function is the original 2 pi divided by that number k, the number k. So it's nothing else, in my case, is 2 pi divided by 2, which is pi. Okay, so that's basically calculating the period, having the coefficient. If I have y is equal to sine 3x plus pi, first we need to factor this 3 out. So this is sine 3x plus, and we factor 3, so I need to divide by 3. Okay, so the number, the compression or expansion, horizontal compression, that would be my number k. So to calculate period of this function, is my period formula 2 pi over k, which is 2 pi over 3. That would be my one period. So whole S shape must be within 2/3 pi. And now we have example. Example 1. Find the amplitude, period, and phase shift of each graph. So we have a y is equal to 2 sine 6x minus pi. As before, we always need to remember to factor the 6 out to see the phase shift. So this one is 2 sine 6 is inside but out, x minus pi over 6. When I took 6 out, I need to divide this one. Okay, so now this letter is my k, and this would be my phase shift. And my amplitude. So the best way to do it is just make a plan about translations, about stretching, moving, expanding the graph. So first we would start with y is equal to sine x. Then we can use either this 2 or this 6, depends what you want. So then I would do, let's say, this 6 sine 6x. So this one is horizontal compression. Horizontal compression by 6 times, horizontal compression 6 times. It affects the period change. Period has changed. So in that case, we can write what is my period. So my period is 2 pi over the coefficient over k, which is 2 pi over 6 divided by 2 divided by 2. So this is nothing else but pi over 3. That's my period. Okay, and then what we would have done, we would have do this 2, because first we go multiplication and then addition or subtraction. So number 3, y is equal to 2 sine 6x. So what does that 2 do? We expand vertically, vertical expansion. Vertical expansion, we expand. Okay, so if my graph, if my original graph is like this, here is my 1. Now when I expand, those are the glue points, this is stretched up to 2. Okay, so what is my amplitude now? What does that affect? It affects the amplitude, because amplitude is the height of one bump. So in that case, my amplitude becomes 2. Amplitude is affected, so the amplitude is 2. And then we would use the shift. So number 4, y is equal to 2 sine 6 x minus pi over 6. So this one is the phase shift. We would move pi over 6 to the right. So the phase shift is pi over 6 to the right. Okay, and in this case we answer all the questions: amplitude, period, and phase shift. So the best way, instead of remembering the formula and get confused what's going on, the best way is just to set up the plan of transformations. What we are doing: number inside we compress horizontally, number outside we do everything vertically. Let's do B. B, we have y is equal to minus 3 cos 3x plus pi over 4. Okay, so first we do need to factor that 3. So this one is minus 3 cos, and then I'm factoring this 3 out. So we have x plus, and what do we get from this part? So normally I would have pi over 4 and then divide by 3. When you factor, when you take 3 out, you always divide each number. So 3 is like 3 over 1. So this is pi over 4 times flip this fraction. So this one is 1/3. So this gives me pi over 12. 3 times 4 is 12. Pi over 12. Okay, and then make the plan of transformations. So first we would have started with the function cos x. Cos x has the V shape. Okay, and then we would do the multiplication either inside or outside, doesn't matter. Multiplication goes first. So y is equal to cos 3x. Period has changed. So what's my new period? This is my letter K. So my new period is, what's the period of cos function? Cos function period is 2 pi. This number is 2 pi. So we have the same 2 pi over k. My k is the number inside, is the coefficient. So this is 2 pi over this number, which is 3. So the new period is 2 pi over 3. And then number 3, we would have done the 3 outside cos 3x. So that's the vertical stretch. We stretch this 3 times. So if my one bump is 1, now the graph is stretched 3 times. The graph is stretched 3 times. Okay, so what's the height of one bump now? Is 3. So my amplitude is 3. Okay, and now we have the minus, first multiplication, so then I would do y is equal to minus 3 cos 3x. What is the minus? We reflect up and down, so this one is vertical reflection, reflect by the x-axis. So it doesn't change my period, it doesn't change my amplitude. It will not get bigger, it will not get more compressed. And then this is the phase shift number 5, y is equal to minus 3 cos 3x plus pi over 12. So this one I would move 12 to the left, pi over 12. So this is my phase shift. You do need to specify whether it's 12, whether it's to the left or right, or you can write phase shift minus pi over 12. That means to the left. Let's do another example, see? See? Y is equal to 4 sine 2x minus pi over 2. Okay, so we do need to factor this 2. So we have 4 sine 2x minus, and what we will get right here, we have pi over 2. And we took this 2 out, so we divide by 2. If you take something out, you divide by that number. So 2 is like 2 over 1. So I have pi over 2 times, flip this over, 1/2. So pi times 1 is pi, and 2 times 2 gives me 4. So this inside I have pi over 4. When I multiply back, I should get my formula. Okay, so as before, I go through transformations. So number 1, y is equal to sine x. Sine x has the S shape. Number 2, I can do either this 2, multiplication goes first, so this 2, and then this, or opposite, that gives you the same answer. So y is equal to sine 2x. So compress, horizontally compress, so that affects my period. So my period is 2 pi over k. My k, this is the number k. So it's 2 pi over 2. So this is pi. Period is pi. Then number 3, I would multiply by this number. So I have 4 sine 2x. So 4 is vertical stretch. 4 is vertical stretch. So if my graph was right here, now it's stretched 4 times. Now it's stretched 4 times. Okay, so what is the height of that one bump? It's just 4. So amplitude is 4. And then we would move it. So number 4, y is equal to 4 sine 2x minus pi over 4, and we move it pi over 4 to the right. So that's the phase shift. Pi over 4 to the right. Now we have example 2. Write the equation of a sine function that has the given characteristics. Amplitude is 4, period is pi over 2, and phase shift is minus pi. So amplitude is vertical stretch. So first we would start with the function sine x, right? Now to stretch it 4 times, I put the number in front. So y is equal to 4 sine x. That's my amplitude, right? And period affects the number inside. So y is equal to 4 sine, I can say k x. I need to find that k. And we do know the formula, we know that period is equal to 2 pi over k. So what is my period in this case? My period is pi over 2 is equal to 2 pi over k. And now I need to solve it for k. When I cross multiply, we have proportion, we can cross multiply. So I have pi k is equal to 4 pi. Then we can divide by pi. This pi and this pi cancel out. So my k is 4 as well. So that's the number right here. So my graph is y is equal to 4 sine, I had the 4, and now my k is 4x. And now we need to put the phase shift. And remember that the phase shift, as we had before, the phase shift is not this number. If you have 4x, you do need to factor that k. So this is your phase shift. So the k, that's basically my k. That k is the number inside but outside. Okay? So in that case, we have the phase shift y is equal to 4 sine, and this 4, and then we have x minus pi, minus pi gives me plus pi. So that's the final answer. Example B. We do need to find the sine curve with those characteristics. So sine curve y is equal to sine x. Amplitude is the stretch, vertical stretch. So that number goes in front to sine x. Now period, we need to find the k, the number multiplied by inside. So y is equal to 2 sine, I put kx. And we know the formula for k, that period is equal to 2 pi over k. So my period is 4 pi is equal to 2 pi over k. But 4 pi is like 4 over 1. Okay? So now I can use proportions. I can cross multiply. I would have 4 pi k is equal to 2 pi. Now I need to divide both sides. I need to divide by 4 pi. So this and this cancel out, and here pi and pi cancel out, and 2 and 4 reduces to 2. So k is equal to 1 over 2. So my graph, my function was right here. So we have y is equal to 2 sine, and my k is 1/2 x. And now we need to put the phase shift. Phase shift is in the bracket. Y is equal to 2 sine, and now we need to put that k outside. Then we have x minus 1/4. Now we have another question. Sketch the graphs, show at least 2 periods. So we have A, y is equal to 2 tangent 2x minus pi over 2. So first thing what we need to do, we do need to factor that 2 out. 2 out, but it's still inside the tangent. So we have 2 tangent, and now I'm taking this 2 out. So it's x minus, and this we will divide by 2. So for this one we have pi over 2 divide by this 2. So divide by 2 is like 2 over 1. Is like 2 over 1. So we can flip this over. So we have pi over 2 times, flip this over, 1/2. Pi times 1 is pi. 2 times 2 is 4. So we have pi over 4. Okay, and they ask us to graph it. So we need to make the plan of transformations. Number 1, I'm gonna start with the tangent graph. Tangent graph has asymptote and halves. And they ask us to show at least 2 periods. So here would be pi, and here would be 3 pi over 2. So that's my tangent graph. Then number 2, we're gonna use this 2 inside. Y is equal to tangent 2x. So this graph needs to be compressed. This graph needs to be compressed. So the period of the original graph period was pi. Now we take the period of tangent, which is pi over 2. So here period would be pi over 2. So we'll try to compress this graph. 0 stays 0. Now the value is pi over 2. We divide by 2. Pi over 2 we divide by 2. So that's the calculation. Pi over 2 divided by 2. So this is pi over 4. So this asymptote now is in pi over 4. So here was pi over 2. Now it's gonna be pi over 4. And this asymptote is minus pi over 2. So now it's gonna be minus pi over 4. Minus pi over 4. Okay, so that's the asymptote right here. And that's the graph, compressed graph. Okay, next asymptote was 3, actually 0. 0 was at pi. Now we divide by 2. So 0 would be at pi over 2. Now the next asymptote is at 3 pi halves. We divide by 2. So we have 3 pi over 2 divided by 2, because we are compressing, so it's like 2 over 1. 3 pi over 2 to divide by a fraction means multiply by its reciprocal. So this gives me 3 pi over 4. So this asymptote now will be at 3 pi over 4. So it's less 3 pi over 4. So it's less than pi. Okay, so here would be pi, and in the middle would be 3 pi over 4 between half pi. 3 pi over 4. Okay, and that's gonna be my graph. So that's the second part. Okay, so we just did the second transformation. Now we have number 3. That's my function. I need to do this number 3 right here. Number 3, y is equal to 2 tangent 2x. So this graph is expanded twice. It's stretched twice. Asymptote will not change. Asymptote will not change, but then it's expanded. So this in the half was 1. Now it's gonna be at 4. So it's gonna be very reminding this straight line. It's basically stretched. You take those two parts and you pull them out. Okay, and so this one is vertical expansion 2 times. And number 4, we're gonna move the graph. So y is equal to 2 tangent 2x minus pi over 4. We will move pi over 4 to the right. So I would just redraw the graph, because otherwise everything would be too messy. So now this asymptote was at minus pi over 4. Now it's moving to pi over 4 to the right. So now the asymptote will be at here's pi over 2. Here is pi over 4. And here's 3 pi over 4. And this would be 2 pi. Okay, so now my graph keeps moving. This asymptote from minus pi over 4 goes to 0. So it's right here. I'm moving the blue graph. And now this asymptote goes 1/4 farther. So it will be 2/4. It was 1/4. Now it's going to be 2/4, which is 1/2. So it's right here. And this asymptote 3/4, moving 1 farther, 1/4 further, so it's gonna be at 4/4, which is pi. And then we have 0, and then instead of having 1, we're gonna have up to 2, 1 and 2. So the graph is stretched. The graph is very stretched. So that's my final answer. B. We would like to graph the function y is equal to minus 3 sine 1/2 x plus pi. Okay, first we do need to remember to factor this number out, inside but out. So this is equal to minus 3 sine, and take this 1/2 out, so it's x, and then I have pi divided by 1/2. Then we have pi divided by 1/2. Divide by a fraction means multiply by its reciprocal, so it's pi times 2 over 1. This is like over 1, so this is give me 2 pi. So then I have plus 2 pi. When you multiply this, when you distribute the 1/2, you do need to get the same numbers. So 1/2 times x is 1/2 x, and 1/2 times 2 pi gives me pi. That's what we have. So now we can make the plan. Number 1, I'm gonna start y is equal to sine x. Okay, sine curve has S shape. Here is 2 pi, here is pi. And the value is 1 and minus 1. So number 2, we can do this 1/2, y is equal to sine 1/2 x. So when it was 2 was compression, when it was 1/2, I'm stretching this twice. So now my period, that one S shape, needs to be 2 pi over k. That's my number k. So this one is 2 pi over 1/2. Divide by a fraction means multiply by its reciprocal. So 2 pi times 2 over 1, which gives me 4 pi. 4 pi. So my one S shape is within 4 pi. Okay? And then I'm gonna do we do need 4 pi, so let's say here is pi, here is 2 pi, 3 pi, and 4 pi, and the same opposite way. So the whole S shape needs to be within 4 pi. So in the middle I have 1, so that's my 1 bump. Here we go. Okay, and the same we could go to the negative 1 to have 2 cycles. Minus pi, minus 2 pi, minus 3 pi, and then minus 4 pi. Okay, so we can have this right here and right here. Oh, that's not right. So the 1 bump right here, right here. Okay. And then we do the 3 outside, so we stretch the graph 3 times. Then we stretch the graph 3 times. Let me just erase it. Okay, so then we stretch the graph 3 times. So number 3, it will be y is equal to this 3 times 3 sine x. So we just stretch it 3 times, and then it would be minus. So y is equal to minus, that would be number 4, minus 3 sine x. So then it would be reflect by the x-axis, reflect, and this is stretch. Okay, so I'm gonna do those 2 steps together. I'm gonna reflect and I'm gonna stretch it. So it was 1, it's gonna be go up to 2, 3, minus 1, minus 2, minus 3. So this bump needs to go down. So from 1 it would be to 1, and now I'm stretching to minus 3 right here. Maybe I should draw the dotted line. And then this bump needs to go up and stretch it, so it's right here. Okay, and the same, this bump needs to go up and stretch it. Smooth curve. And then this bump needs to go down and stretch it right here. Okay, so this one is my minus 3 sine minus 3 sine x, and now we have plus pi 2 pi, so we are moving 2 pi to the right. So 1 and 2 pi to the left. So number 5, y is equal to minus 3 sine 1/2 x plus 2 pi. So in that case, 2 pi to the left. 2 pi to the left. So the blue graph is moved 2 pi to the left. So this point goes right here. And now we have bumped down. And then bump down and then goes up. And the same here. This part is moved, so now this part needs to be moved. So we have bump up, and that would go next one, bump down. Okay, so the red graph is my final answer. I'll try to bold it. The red graph is my final answer.